Question 8 is coming from arithmetic progressions. Part A, the first three terms of an AP are 25, 4p minus 1, and 13 minus p, where p is a constant. Find the value of the 10th term of the progression. Then that means we need to get the first term is given. So we need to get the d, which is the common difference. So the first term is a, which is 25, right? And then a plus d, that is the second term, is 4p minus 1. You see that? Then from here, that means d is going to be equal to 4p minus 1, then minus this a when it crosses the equal signs, but a is 25. So this one gives us 4p, then minus 26. Now we have the third term here, okay? The third term is a plus 2d, which is equal to 13 minus p. So since I have d here in terms of p, I can be in position to also put it here. Already a is 25, then plus 2 times this 4p minus 26, which is equal to 13 minus p. So I have one unknown here, which is p. So I can get the value of p, and then from there, I get the value of d, then I can be in position to get the 10th term. So this will be 25, then plus 8p minus 52, then is equal to 13 minus p. When this p crosses here, it will add up to this, so we shall get 9. That will be 9p, then 13. When this one crosses, it will become a plus. So plus 52, that will be a 65. Then minus the 25 when it crosses, that one will give us a 40, right? So p is going to be equal to 40 here, then we divide by the 9. So this therefore implies that d is going to be 4 times p, this one here, then minus the 26, okay? Now, what do we get here altogether? Let me first simplify this one here. 4 into 40 out of 9, then minus 26. This one gives us negative 74 over 9. Negative 74 out of 9. Now we need the 10th term. So the 10th term, of course, is equal to a, then plus 9d. So a is 25, then plus, this is 9, then times d is negative 74 over 9. Don't you think this 9 disappears? And then we remain with 25 minus 74. Okay, 25 minus 74, that one automatically gives you negative 49. So that is negative 49. That is that. Part B, the first three terms of a GP are the same as the other ones, right? But where there is P, they have put Q. So where Q is a positive constant, find the sum to infinity of the progression. Now we need to find the common ratio. So the first term, A is 25. Then AR is 4Q minus 1. And AR squared is 13Q minus Q. Now, to get the common ratio, you get the preceding term divided by the preceding term. So, common ratio is equal to the second term, okay, divided by the first term. It is the same thing you'll get when you say third term divide by the second term. Okay, this is what I mean as the preceding term, then the preceding. Okay, so that means we can have the second term is this one here, 4Q minus 1, then out of 25, this one is equal to 13 minus Q out of 4Q minus 1. Then when we cross multiply, we shall have 4Q minus 1, then squared will be equal to 25 into 13 minus Q. That means here we are going to get a quadratic equation, which is going to give us the values of Q, and we take one value, which will give us the R value, that can give us the sum to infinity. So square here, this one will give us 16q squared. Then this times that, that will be negative 8q minus 8q, then plus 1, then 13 times 25, that is 325. So 325 here, then minus 25q. I bring everything this side to form one quadratic equation, which is 16q squared. Now minus 8, then plus 25. That will be a positive 17, yes, positive 17q. And then this one, when it comes here, it will be a minus, so we shall have minus 324, which is equal to 0. This one, we can just put in the calculator and then we solve straight away, but you have to show the examiner that you have solved the equation. I'll go to equation, that is option 5, then 3, that is quadratic, we shall put 16, then 17, and then minus 324. So this one gives us a 4, and then negative 81 over 16. So Q is equal to negative 81 over 16, and also Q is equal to a 4. So what you need to do here to cheat the examiner, you have seen that I've left space here. You have to show the examiner where you got these values, okay? So I can cross multiply. We need to get to the factor from which these roots come, okay? So when we cross multiply, we shall get 16q, which is equal to negative 81. Then you bring the 81 back. So that will be 16q, then plus 81. And then you bring this one here. That simply implies that you will have q minus 4, which is equal to what? 0. Now, they said that the q value is a positive 1. So that means I'm going to take this 4 here. Okay? So therefore, my value of q is going to be this 4 here. So what will be r? Remember r, I can use this or this one here. So by using the first one, that is 4 times 4, which is 16, minus 1, that will be 15, then divide by 25. So 15 out of 25, when I divide all through by 5, here I'll get a 3, and then here I'll get a 5, okay? So sum to infinity is equal to a out of 1 minus r, and r ranges from negative 1 to 1, okay? And this value we have gotten here actually fits here because it is 0.6, you see? So let's check in here. A is 25, then 1 minus our r is 3 over 5. So what do we get altogether? 25 divided by 1 minus 0.6. That is 62.5. 62.5. As simple as that.